Hey chemistry students, this is Mrs. Miller, and today we're going to be talking about how to solve some pH and pOH practice problems. You guys are going to want to have your red reference sheet out that has the pH and pOH triangle on it to help you guys with some of these equations. You're also going to want the pH and pOH practice problems out because we're going to be doing a few examples from that sheet as we go through these questions today. You are going to want some sort of calculator, whether it's one of the calculators that we have in our classroom in the white bin, or if you want to use your iPad, just be sure you know and understand how to use your calculator. In Canvas, there is an activity, or I'm sorry, there is a Google Slides presentation that talks about how to properly use your calculator with pH and pOH. So it's called the pH calculator steps, and that is in the pH and pOH practice problems. So if you want to view that before you get to this video, that's just fine, but that just has the steps on how to actually input these values into the calculator. All right, so where we're going to start is actually kind of like a little review. If we are given some sort of an acid, we need to know what type of ion an acid produces. So an acid is going to be giving up a hydrogen or hydronium ion. H plus is usually how we're going to write it. And if we have H plus, we can calculate pH. And pH literally stands for the power of hydrogen. So that's why the H is capitalized, because it's representing an element on the periodic table. So if I want to calculate pH, what I'm going to do is I'm going to take the negative log of the concentration of hydronium ion. So that's what I have to plug into my calculator. So for example, I have 0.0035 molar hydrochloric acid. If I have that, because I have hydrochloric acid, I know it's going to be giving off hydronium ion, H+, so I know that the hydronium ion concentration is 0.0035 molar. So acids give up hydronium, and that same concentration is what I'm going to use. So if I want to calculate the pH of the substance, I just need to take the negative log of the hydronium ion concentration, or in this case, I'm going to take the negative log of 0.0035. So I'd love for you guys to try that and put that in your calculator, because sometimes you're not going to be able to put that in your calculator properly, or you just don't the right time. So go ahead, give that a try. Plug in negative log of 0.0035 into your calculator, and let's see if your answer matches my answer. If you put this in properly, what you should end up with is 2.46. If you are not getting the correct answer for this, please go into Canvas under the pH and pOH notes and practice problems and locate the pH calculator steps. That is going to show you how to properly put this value into a calculator so you are getting to the same value as I am. Try it again and see if you get 2.46. If you do, then you're ready to move on. If you use your red reference sheet, we can also see that if now we're given pH, we can calculate H+, or hydronium ion concentration, because according to our red reference sheet, H+ is equal to 10 to the negative pH. So we're going to go 10, negative pH. Example, if I have a pH of 4.5, to calculate out the hydronium ion concentration, I would simply take 10 to the negative 4.5. So when I plug that into my calculator, I go 10 to the negative 4.5, I end up with 3.16 times 10 to the negative 5th molar. You go ahead and you try that in your calculator and see if you're getting to the same answer. If you are not, again, go into Canvas and find the pH calculator steps, because you need to take a look at that and see what you are doing wrong to not get that right answer. Now you hopefully understand how to get pH or hydronium ion concentration, but what if we have a base? A base doesn't have hydronium or a pH. Instead, a base is going to have other things. So on the pH and pOH worksheet, you'll be given a concentration of acids and bases. How do we go about calculating the pH of a base? Well, again, this is where that red reference sheet is going to be really handy with that triangle. So let's take a look. An example we have is, what is the pH of 6 molar NaOH solution? All right, so we have 6 molar NaOH. Step 1, look at the formula. When this compound breaks down into ions, are you going to get H plus or are you going to get OH minus? So I look at this formula, NaOH. Obviously, when I look at that, I see an OH, so we're definitely going to get hydroxide ions out of this, okay? So that's not something that we've worked with before, so let's take a look at how to do this. When you look at your red reference sheet, what you're going to see is you have OH concentration that can go into pOH. You can also take OH concentration and go into H+. We're first going to follow this side of the sheet because we eventually want to get to pH. Notice that there's no arrows directly between OH and pH, so we have to do something different. If I have a hydroxide ion concentration, I can take the negative log of that and I can get pOH. So really similar to what we did with pH, when I have H+, I can do the negative log of H+, and I can get the pH. So if I have OH minus, I can take the negative log of that and get pOH. So that's where we're going to start. And when I go ahead and I do this, I have 6 molar NaOH. So that means I have 6 molar OH minus concentration. So we have the OH ions. You can calculate the pOH. pOH is the negative log of the hydroxide ion. So negative log of 6, because that's our hydroxide ion. And when we do that, we get negative 0.78. A lot of students get bent out of shape because they're like, oh, it's a negative. You can't have a negative. Yes, you can. You do not have to stick with the 0 to 14 scale. You can go negative, so that is completely okay. So currently, our pOH is negative 0.78. Our next step is now that we've gone from OH minus and we've gone into pOH, we should then be able to get into pH. So guess what? If I have pOH, that is going to be equal to 14 minus the pH, and I want to get to pH, so we just need to rearrange that equation a little bit. We already did this first part, and we took our OH ions, we calculated the pOH by doing the negative log of the hydroxide ion concentration, so negative log of 6 was negative 0.78. Next, we want to change our pOH into pH. pH is equal to 14 minus the pOH, so 14 minus negative 0.78 is equal to 14.78, and that would be the pH of this solution. When I look at that, 14.78 is very basic or a very high number, so that would be a base, which goes along with what I'm thinking it should be, which is perfect because bases, remember, are above 7, and because this is a base, my pH should end up being above 7 as well. Perfect. My next question that I have here is find the hydronium ion concentration and the hydroxide ion concentration in healthy human blood with a pH of 7.4. All right, we've been given a 7.4 for a pH. That's going to help us with a little bit of information, so let's take a look at our reference sheet. If I have pH, I can easily calculate out the H plus ion concentration by taking 10 to the negative pH. So that's what we're going to start with first. We're going from pH to H plus ion concentration by doing 10 to the negative pH. If I go ahead and I do that, calculate the H plus. So human blood has a pH of 7.4. So H plus concentration is equal to 10 to the negative pH, or 10 to the negative 7.4. Plug that in my calculator, and I end up with 4.0 times 10 to the negative 8th molar. All right? After I have that, again, look at your reference sheet. You can easily go from H plus to OH minus, and we can calculate out the hydroxide ion concentration. So to figure that out, we're going to use that equation where 1 times 10 to the negative 14th is equal to H plus. That's a really crappy plus, but you guys get it. And then OH minus. If we go ahead and we rearrange this equation right here, we end up with 1 times 10 to the negative 14th divided by hydronium ion concentration, which we already know is 4.0 times 10 to the negative 8th. So we do 1 times 10 to the negative 14th divided by 4 times 10 to the negative 8th, and we find out that OH is going to end up being 2.5 times 10 to the negative 7th. Our hydrogen ion concentration is 4.0 times 10 to the negative 8th. Okay, so using that red reference sheet and using your calculator properly are going to be very, very important. You guys just have a few questions on these, so if you have any questions, let me know. Otherwise, have a fantastic day, and don't forget to use the reference sheet and your calculator properly.